Hello. Today we are simplifying radical expressions. So please try this problem. Give you a little time to look at the problem, call any strategies, and then I'll go over it. Okay, that should have been enough time to write down the problem. So let's attack this. We want to simplify a radical expression. So the main idea, main key in simplifying these kind of problems is understanding the principle of division. So if we wanted to divide 9 over 5, we might have learned it this way. It's 1 remainder 4. In the same way, if we want to take the fifth root of something like x to the ninth, then we are in essence dividing 9 by 5. We get x to the first, and whatever's remaining we leave inside. So we get x to the first, fifth root, x to the fourth. This can be written as x, fifth root, x to the fourth. The other principle to understand when simplifying radical expressions is that you want to simplify them individually. So if you see fifth root of 64 x to the ninth, what you can do is simplify this and then simplify the x to the ninth. That way you're breaking a problem down into 2 mini problems instead of being intimidated by every single term. Because eventually there will be possibly 4 or 5 terms in these kinds of problems. So, to attack this problem right here, I'm going to start with the left expression. 4 times the fifth root of 64 x to the ninth. First, to deal with the number 64, we want to find fifth roots that divide into 64, so perfect fifths. So if we think about the powers, 1 to the fifth is 1, 2 to the fifth turns out to be 32. And that's beautiful, because 32 divides into 64. So we can simplify this expression as 4 to the fifth root of 32 times 2, which is 2 to the fifth, times 2, x to the ninth. And now the 2 over here can come out and go over outside of the radical. So 4 times 2, fifth root, 2x to the ninth. This becomes 8 times the fifth root of 2x to the ninth. And now we can simplify x to the ninth as x, fifth root, 2x to the fourth. So that is our first term. Do you look at that? See if that makes sense. Now we'll move to our right expression. The 2 stays on the outside. The fifth root of 16. Well, if we go through our perfect fifths, we have 1 and then 32, so neither of them qualify. But the x to the 11th, we can break up. 11 over 5 equals 2 remainder 1, which means our exponent is x squared, fifth root of 16, with a remainder 1. So I have x remaining. So we've simplified the left side, the left expression, and we got this, and we simplified the right expression. Now we can multiply them together. 8x to the 5th, 2x and 2x squared create 16x to the 7th. The fifth root of 2x to the 4th times the fifth root of 16x gets us the fifth root of 32x to the 5th. And now we notice that 32 is a perfect fifth, and the fifth root of x to the 5th ends up being just x. So the radicals go away. We get 16x to the 7th times 2x. So our final answer is 32x to the 8th.